Well, good morning and welcome to our first Mapemath lesson, which is touching on algebra, grade 9. That is going to be done next year, but it's good when we do things early. It's good to do things early. Mapema, your best. All right. Tuned in. In today's program, we are going to identify matrices, look at the order of the matrices, and the element positions in those matrices. We'll also consider the compatibility of the matrices, the addition and subtraction of these matrices will also be discussed. Item, that is identifying matrices. How can we be able to identify or know that this is a matrix, and what exactly is a matrix? So I want us to imagine or look at the way we present our information or data. Normally we put them in tables, and in tables we give the column names, we give column names and row names. Let's look at an example of the table that I've been able to just pick from one of the materials. That in table 1 we have this information. We have the information of two learners. The first one Mwende and the second one is John, and we are trying to look up at the items these learners possess. That is an exercise book and the pens in a given class. We say even in our class. Okay, so Mwende has 6 books from the table. That's what you can interpret, and she has 2 pens. But John, looking at John, he has 4 exercise books and 1 pen. So is this the only way we can be able to represent information? Although it's a better way, you can just look at it and be able to easily understand that this is communicating. Now, if you represent information in a table format, then it's possible after you have understood that information, you know what exactly the information means, there is another way you can be able to represent it, and that way is matrix. So you can represent this information from this table in form of a matrix. So let's see what happens when we want to transfer the information from the table to a matrix. So this from the table to our matrix. There you go. The table and the matrix. So look at that. There is the matrix. As simple as that. Now you will realize that we have ignored the what? The column names. Learner, exercise book, pens have been ignored, and the row names have also been ignored. So in this matrix we don't use the headers. Why? Because we have understood our information from the table. Good. So that 6 is represented in a matrix at that particular position, and then the 4 exercise books for John will be placed just in the same column below the 6. All right. Then we have the pens for Mwende. They will be placed in the second column but the first row. You see, the table design remains, but in the matrix we don't use the names, we just use the values. There we go, we have 1 and 1 in that particular position. Good. So how can we be able to get the meaning of a matrix from this kind of an illustration? We say that a matrix is a square or rectangular arrangement, and this is an arrangement of numbers. So it is a square pattern, a square or a rectangular pattern that is formed when we arrange numbers in rows and columns. I hope you've seen that we've actually arranged 6, 2, 4 and 1 in this first row and second row, then first column and second column. We shall see more about that later on. So that's the definition of a matrix. The next, I want you to try this. Identify a matrix from that table. Just pause a little bit and identify the matrix from this table using the initial introduction. I'll be here, I'm waiting. I know you got that already. You got that. So you start. But mine is going to disappoint you because I know you picked all the numbers. Mine, because I talked about understanding, then I'm going to give that. That is my matrix. Why? I understand the first and the second columns already. I know the first and the second column contains team and number of matches played. But if you wrote 777, still okay. In your matrix, if you wrote 777 as in the first column, you are very right. So you notice that the rows and the column names are ignored. You don't use them. Why? Because you have already understood what that table is containing. Okay, identifying matrix still. Let's look at the other examples. I have given several of them. The first one, A, B, C, D, and then the second one, 1, 0, 5, is actually a column matrix, normally used to represent vectors. You learn that later. Then we also have that 3, 2, 9, 4, 6, 1. It's another matrix. Then we have 13, 9, 6, 7, 8, 10, 1, 14, 5. That is also another example of a matrix. Remember that it's not about the positive numbers alone. You can even have fractions, you can have negative numbers, you can have letters mixed with numbers. As long as they form that array or arrangement, that becomes a matrix. Are we okay? Fine. So I want you to try that. It's actually very, very easy, very easy, very easy. Just try to write two matrices from your calendar. Imagine you are not restricted. You know which days are there. You know, okay, which month is that you are representing. So just putting any square or rectangular arrangement and it will give you a matrix. But not that. You must put the matrices in brackets. You don't just write or throw about numbers. You have to put them in brackets. And another thing, very important, that those numbers you write in brackets, you stop calling them integers, you stop calling them letters, you stop calling them decimals or so on fractions. No, they have a name. So the numbers in a matrix are called elements. They are called elements. All right, good. The order of matrices. Order members, there goes our speaker. Okay, that is not the order he talks about. The order we are going to talk about here is the order in terms of arrangement. How are they organized? So how are they organized? Now, the order of a matrix is normally given by the number of rows in that matrix by the number of columns. Number of rows by number of the columns. So rows are horizontal, columns are vertical. They are vertical. Okay, so look at this example here. We have the matrix 6, 2, 4, 1. Matrix 6, 2, 4, 1. So in this matrix, we have how many rows? Let's count. The first row, the second row, and we have the first column, the second column. Right, so only 2 rows and 2 columns. So what will the order be? Using this formula here, that the order of a matrix is given by number of rows by number of columns. So we shall get that the order of our matrix becomes 2 by 2. Not that you don't give the answer at 4. No, 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 no. You just write it 2 by 2. Just write it the way it is, 2 by 2. Very well. So that is the order of our matrix. We are clear. Now, problem with math teachers, they will always give you the directive or guide you and then ask you a question. So write down the order of the matrices below and use the order formula to give you the finding. So order is given by the number of rows and the number of columns. So there you go, the first matrix. Oh, let me do for you the first column, the first row. I've done for you. For the first matrix, the first row. That's a hint. Let me see. Once you get it, you have some approval. I'm going to give the answer. 1, 2, 1, 2, 1, 2. The first one, you should have gotten it. So easy. What about the second one? Try it. Try the second one. Don't fret. It's easy. Count the number of rows, count the number of columns. Then say order is what by what. There, the first one we had the first row, second row is there. Then the third row, first column, second column, and third column. So our order is 3 by 3. The number of rows are 3, represented in red rings. My red cap, I don't like red. Yeah. And then columns, 3 of them also black, because I'm a black African. Then in the second one we have row 1, we have the second row, we have the third row, then we also have the first column and second column. So our order is going to be order of 3 by 2. Sorry, my camera is hiding this part, but that is it. 3 by 2. So the order is 3 by 2. Very nice. I hope you are okay with that. We move on to the next one. Identifying the element position in matrices. Remember, I say the numbers which are in a matrix are called what? Elements. They are elements. What is enclosed in that bracket is an element. So how do we get the positions of elements in matrices? Here we go. Look at these ones. We have matrix X with elements A, B, C, D, E, and F. We have those matrices. The second one is Y, having numbers, but they are not numbers, they are elements. 13, 9, 6, 7, 8, 10, 1, 14, and 5. So how can we get the positions? We can get the positions of an element and represent them by looking at the row number and the column number. But we start by writing the element itself. So you write A, okay, and then write A is in which row? In row 1. It is in which column? Column 1. So A is here in the first row, in the first column. So the position of A is going to be A itself as an element, followed by the row number, it is in row 1. The column number, it is in column 1. But how are they written? In subscripts. Get that clear. They are written in subscripts. Subscript, the number below. Let me give you how we are going to present that. So in the first matrix, X, A is in position 1, 1. Element B is in position 1, 2. The first row, second column. Element C is in position 2, 1. The second row, first column. Element D is in position 2, 2. Second row, second column. Okay, these are going to represent the row number, column number, row number, column number, row number, and column number. So F is in 3, 2. So if someone gives you a question and asks you to write a matrix with this kind of arrangement, you will be able to get it easily because they have given you the order. Can you arrange yourself? You tell these elements to arrange themselves the way you guys just organize yourselves in a pattern or a setting, not knowing that you are behaving like elements in a matrix when you are in that class. Oh, sorry for that. Sometimes I anachokoza anachokoza watu. In the second matrix, we have the elements. Element 13 is in row 1, column 1. Element 9 is in row 1, column 2. Element 6 is in row 1, column 3. That's why we can see how they are presented. That's how they are presented. Now, can you give this a shot? Try this, try this, try this. We have those two matrices. And you can see for A, the first matrix, I've already given you everything. It is a matrix. Element A has been assigned with the position already, okay? But in B, that's where I want you to try. That's where I want you to try. Oh, by the way, you need to note that the matrices themselves are represented by capital letters. This is matrix A. And then the elements in them are represented in lower cases, or if they are just numbers, no problem. So that is what you need to know. You don't write A is equal to, put here a capital A. No, that will be a wrong approach. So the first one, you already see that those are the positions of the elements in that matrix. Those are the positions of the element in that matrix. Good. What about the second one? I want you to try the second one. But in the second one, I want to find those positions. What does A represent here? This A, what does it stand for in the second matrix? This B, what is the value of B in the matrix? What is the value of C in this matrix? Just try getting the values. Instead of the letters, put the numbers there, the elements in number format. Waiting. Good, I know you got it. This is it. 13 is A. Why? Because it is in position 1, 1, row 1, column 1. 9 is B. Why? It's in row 1, column 1, column 2. Good. 6 is the C. As you continue till you get to the end. So if matrices have the same order, then those matrices are said to be compatible. Like I was just saying somewhere else, you cannot use type A charger to charge your type C smartphone. You have to do what? Use the charger which is compatible. You have to use the compatible charger. Oh, I have to wear a cloth that is compatible with my body. I can't wear a cubicle cloth. How will my hands fit? All right, so they are compatible. My cape has to be compatible with my head. What if it was a flat cape? Then it would not be compatible. All right, sorry for that. That was just by the way. Okay, consider the matrices below. Matrix A 6241 and matrix B 1327. In that case, we also have matrix C 016227. So the order of the first matrix is 2 by 2. Why? It has two rows 1, 2, and 2 columns 1, 2. Okay. The second one is also of order 2 by 2. Then the third one is of order 3 by 2. So in this case, you can see A and B have the same order. Therefore, they are compatible. These are the compatible matrices. Why? They have the same order. can only add matrices which have the same order. Let's try this. I have two matrices here, 6 2 4 1 1 1 3 and 2 7. Can these two be added? Yes. Why? They have the same order. The first matrix is of order 2 by 2. The second one is also of order 2 by 2. So I can easily add this. Why do we say that matrices must be compatible for us to add them? It is because you will be able to get the elements in certain positions, sharing the position, and therefore can be added. But if we have different order of matrices, then it means the elements will not be sharing any positions and they will never be able to be added. So let's look at this. How do we add this? We take the element 6, which is in position 1 1, row 1, column 1. We add it to the second element, which is 1 in the second matrix, also just in the same position 1 1. Okay, so that is why we say 6 plus 1, and the same happens to 2 plus 3. Remember, they share the position. 2 is in 1 2, 3 is also in position 1 2. So that's why we add them in that particular manner. Now this will be our answer. So 6 plus 1 giving us 7, and then let's take it slow a bit. Okay, there, 1 plus 7 giving us the 8. That gives us the 8. That's how we add matrices. The general formula or concept, because that's what you will use, the rule that you will use over and over again to add matrices after confirming their compatibility. So look at this. If you have matrices A, B, C, D and matrix E, F, G, H, you can add them because they are of the same order. They are compatible. Don't forget that. They have order 2 by 2, 2 by 2. Now, how do you add them? You take only those elements that share a position. In the first matrix, in the second matrix, same position. You add them. So A and E are in row 1, column 1 in both the matrices. So they are the ones we add. So in our answer, we'll have A plus E. Then we'll have C plus G because they are in the same position. B plus F, D plus H. I hope you get that. So A plus E giving us that. Then B plus F giving us that. Then we'll also have C plus G. C plus G giving us that. And we can also have D plus H. So that will be our complete addition of the matrix. Lastly, I dive into the subtraction of matrices. Also, only matrices that have the same order can be subtracted. The ones that are compatible. You can't subtract matrices that are incompatible. That one you can. If you can, then actually you go to the Guinness Book of Records. Yeah, for having done an impossible. Okay, consider these matrices the same. We have the elements as shown, those ones are in numbers, so the same as addition. You just need to subtract the elements that are in the same position. Elements that are in the same position, you can only subtract those ones. So you'll have 6 minus 3. Why? Because they share a position. 6 and 3 can be subtracted because they are in the same position. Row 1, column 1. Another one, so that gives us 3 in our final answer. Another one is 2 and 1. 2 2 and 1 can be subtracted. So 2 minus 1 giving us the 1. Then we also have 4 in row 2 and column 1 corresponding to 2. So 4 minus 2 giving us the 2. Then we also have 1 and 0. So these ones are in the same position, so we subtract them and we'll get a 1. Is that okay? Now, perfect. So general subtraction of matrices. If you have A, B, C, D as your first matrix, you are subtracting another matrix, E, F, G, H. You follow the same rule. They are not different as that of addition. So you have element A in the same position with element E can be subtracted. So you have A minus E. And then element B and F, they share a position, so you can subtract those ones. Then element C and G can be subtracted. Then D and H, lastly, they can be subtracted also. So we get that D minus H. So any other matrix that you have been given to subtract, you'll have to follow that procedure. Have you noticed something? That if you are subtracting or adding matrices of a certain order, they are compatible. Say 2 by 2. All of them are compatible in that 2 by 2 matrix. Then you need to find an answer that is similar, has the same answer, okay? It has the same order. The answer must have the same order as the matrices that you are adding or subtracting. So that's what you need to know. Well, I hope up to that particular point, all of us have been able to get the new concepts. We have understood. Have a good day to the class break. And thank you very much for coming. See you next time. Shall be looking at linear equations and the linear inequalities. So the two, and we call algebra the end. So if you have any questions, just contact me through any of those links or numbers you have.